Let's understand the confidence interval of the mean with the help of an example. Suppose we have a sample whose size is equal to 9, n is equal to 9, the y bar or sample mean is 80 and sample standard deviation is 15. What interval will contain the true population mean 95% of the time? So here we are looking for the 95% confidence interval. Alpha over here will be 0.05 or 5%. This is the equation for confidence interval. We already covered that. Now we look into this part. Alpha is 0.05 here, and since it is two-sided, so we look for both the left side as well as the right side. So towards left, this alpha is, we will look the value for 0.025 in the table and find the corresponding z value. If you go to the table, this is the left side of the table. So first we're gonna search in this probabilities section. So here these are probabilities and these are your corresponding z values. This is table number 1's standard normal curve areas are z table or z table. So these two digits minus 1.9 will be taken from here, and this second digit from the from this decimal point will be taken from here. So whichever column has your probability. So this 0.025 we look for in this whole thing and we found it here. Now we look for the corresponding z value. So over there it is minus 1.9 and then we add this 6 here. So it is minus 1.96. Plug in the value. Same way, if you want to calculate the value towards right, you should look for 0.975. Standard error is given by standard deviation divided by square root of n, so it is 15 divided by square root of 9, so we'll get answer equal to 5. So confidence interval can be calculated as mean plus minus z at that particular alpha by 2, and we will take its absolute value to avoid the negative signs. And then we multiply this with the standard error, and this whole thing will be added to the mean, the sample mean. So finally we get 80 plus minus 9.8. So the lower level or lower confidence level or confidence interval will be 70.2 and the upper is 89.8. So it looks like, so 80 in the middle and towards left the lower interval, and towards right is the upper interval. So towards left is 70.2 and towards right is 89.8, while 80 in the middle. So these bars actually they represent the confidence interval, the range of the confidence interval. So towards left, if you see, this whole area is 9.8 because 70.2 plus 9.8 will make it 80, and this towards right is again 9.8. The total width of this confidence interval is 9.8 plus 9.8, so that is equal to 19.6. So we can say width is equal to 2 times this margin of error thing. So that thing we actually called it as, this 9.8 was margin of error or marginal error. So width is equal to 2 times E. We'll need that when we do the next topic, that is the sample size estimation. Here is a diagram that shows you the success of getting the actual mean by this technique, this using confidence intervals. So here we have those suppose 20 confidence intervals, and we plotted them, and in the middle this line represents the mean, the population mean. So suppose we did this 20 times, and at the probability of 5%, 19 among us them would be picking up the population mean, and that's what happens. Only one of them is off, so this thing is we can say that 95% of our these these results are good enough to capture the population. Let's look this thing again. So we have this mu in the middle. This was the area for alpha, right and left, and the area in the middle is the our confidence region. We can also say that 95% of the y bars, they actually lie in this interval. So this is the true mean, and as we have seen in the previous diagram, now we can see it here and plot it here in this curve that 95% of the y bars, the sample means, they lie in this region, like they can capture the true population mean. Common values of the confidence coefficient 1 minus alpha by 2 and corresponding z values. If alpha is 0.1, that is the probability of error is 0.1 or 10%. Our confidence coefficient 1 minus alpha is 0.9. Here we are constructing a 90% confidence interval. Corresponding z value for this alpha by 2, z at alpha by 2, no, alpha by 2 will be 0.05. We'll take this 0.1 and split it into two halves, so that is 1.645. If it is 0.05, we have already seen that it is 95% confidence interval. The value of alpha by 2 is 0.025 and the corresponding z value is 1.96. Same way for 0.02, 98%, 0.01 here, 2.33, 0.01, which is the 99% confidence interval. The value of alpha by 2 is 0.005 and corresponding z value is 2.58.